Okay, this problem right here, this quadratic equation, is asking us to solve so that we have two equal roots. So when we're talking about two equal roots, we're talking about like x minus 3 quantity squared equals 0. We're talking about 4x plus 1 quantity squared equals 0. In which case, the first one, the roots would be x equals 3 and x equals 3. That would be a multiple root. Here, x equals negative 1/4, x equals negative 1/4, and that's because, when we expand this, we'd have two equal roots. So we want that to be the situation for this problem that I'm posing on the left-hand side. So what do we do to get this? Well, this is called completing the square. So we want a perfect square trinomial. So I'm going to move everything over to the left-hand side of the equation. So I'm going to subtract 2x times the quantity 3k plus 1, and I'm going to add 7 times the quantity 2k plus 3, and then set it equal to 0. And now I'm going to make it look like, ax squared plus bx plus c equals 0. So I want that x on the right-hand side, and then I want all of the coefficient in front of it. So that's what I'm going to do here. I'm going to multiply the 2 and the 3k plus 1. So that's going to be minus 6k plus 2 times x. And if I were to multiply this back out, just to show you, minus 6k, minus 6k, minus 2, minus 2. And then, of course, the x is on the right-hand side, so that would all work out. And I'm going to distribute this as well. And now I'm going to use some highlighter here. Here's my coefficient for the x, the linear term x, and here's my coefficient or my constant term. Not a coefficient, a constant term. Now when we complete the square, we want half of b, okay? So we want half of b, and then you square that, and that's going to equal your constant. That's how we complete the square. So if you go back to the videos and completing the square, that's what we're doing to complete the square. So that's what I'm going to do here. I'm going to take half of this term, 6k plus 2, and I'm going to square it, and that's going to equal my constant, 14k plus 21. So I'll distribute the 1/2 first. I get 3k plus 1, and that's squared, equals 14k plus 21. That's 9k squared plus 6k plus 1 when we expand it, equals 14k plus 21. I'm going to solve this by subtracting 14k from both sides, subtracting 21 from both sides, and now I'm going to try and factor this trinomial. I'm going to go with 3k and 3k. I'm going to go with 4 and 5. I'm not sure if this is going to work. 12 and 15, that is not going to work. Let's try 10 and 2 maybe. 10 and 2. 10 and 2 is not going to work. 20 would be 10 to 110. 120, that's not going to work. So maybe we've got 9k and 1k. And now maybe I've got 4 and 5. No. 2 and 10 maybe. 18, 10, that's it. Negative 18 plus 10. So that was a good review right there, hopefully, for you in factoring trinomials. Maybe you got it faster than I did. That's a good thing. And our two values of k would be negative 10 ninths and positive 2. So those two values for k, when put back in to the original equation, would create a perfect square trinomial. So let me show you that in red. Here I'd have x squared equals 2x times 3, and then I'm going to put that negative 10 ninths in for k. And I again, I'm going to put that negative 10/9 in for k. And we've got x squared equals 2x. And that's going to give me times negative 10/3 plus 3, that's all in, plus 1, that's all in parentheses, minus 7 times negative 29 plus 3 in parentheses, x squared equals 2, let's distribute that, negative 20/3 x plus 2x plus 140/9 minus 21. I'm going to combine like terms. X squared equals negative 26/3 x, not negative 26, that would be negative 20 plus 6 would be negative 14/3 x plus 140. Let's see if I get that common denominator. I'm going to have 189 minus 140. That's 49/9. So that would be a minus 49/9. And let's see, x squared plus 14/3 x plus 49/9 equals 0. I'm going to take half of 14/3, which is 7/3. And that is how that factors. X plus 7/3 quantity squared. So I'd have x equals negative 7/3 multiplicity 2. Now that's the harder one. I just checked this harder value of negative 10/9 because putting fractions in, as you can see, is not the most delightful thing in the world, but you try putting the 2 in. You're like, put the 2 in for what? Put the 2 in for k, and you should end up with a trinomial, like I did, that is factorable to a binomial squared. And that's how you'll know that you have a multiple root. So I hope this video helps explain and reinforce completing the square. It's a very important technique in our math from here on forward.